Hi, guys. Today we're going to be talking about the distributive property. I actually just realized I need to back up a little bit. I'm on slide 6. I want to start you over here on slide 1. So today's investigation, the problem can be found on 4.2. I can get you that page number in just a minute. But we will be talking about, like I said, the distributive property. So multiplying the sum of two or more addends by a number will give the same result as multiplying each addend individually by the number and then adding the products together. So the sum of two or more addends by a number, we've got 3 plus 5. 3 plus 5 equals 8. 2 times 8 will give us 16. So what this property is telling us is that 2 times 3 plus 5 is going to give us the same answer as 2 times 3 plus 2 times 5. I'll give you a minute to go ahead and look at that and see if you agree. All right, so here's a model, a couple of arrays that can prove to you how this distributive property works. If you take a look at the array I have right here, we can see that it's a 2 by 3 array. So 2 times 3, of course, the area of this would give us 6. We've got 1, 2, 3, 4, 5, 6. And then, of course, we have a 2 by 5. So that's 1, 2 by 1, 2, 3, 4, 5. 2 by 5 is giving us the area of 10. So if I go ahead and count all of these cubes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, you can see that I come up with, you can see that you come up with 16. Similarly, when I look over here, you can see that even though I've got these addends inside of the parentheses and I'm adding them together first and then multiplying by 2, you're going to see that I'm still going to get the same area or the same product. So I've got 1, 2 by 1, 2, 3 plus 1, 2, 3. Oops, let me move me here. I'm in the way. Okay. 1, 2, 3 plus 1, 2, 3, 4, 5, right? 3 plus 5 is 8. So a 2 by 8 is also going to give us 16. Let's take a look at the next slide. So as you can see, the distributive property connects addition and multiplication. So I want you to take a look at this term here. I've got two terms, right? I've got one term here and one term here. Term is definitely an algebraic vocabulary word, so let's go over that. A term is a single number or a product of several numbers which will be separated by an addition sign or a subtraction sign found in expressions and equations. So this plus sign is right here. So I know that 2 times 3 is a term, as well as 2 times 5 is also a term. So on this side of our equivalent expression, on this side, we've got the sum of two terms. So that's 2 times 3 plus 2 times 5. Now, when we come on over here, we can see how distributive property tells us that we can also write this as 2 times 3 plus 5. So this is the product of two factors. One of the factors is 2, and the other factor, of course, is going to be 8. So essentially what we're saying here is 2 times 3 plus 2 times 5 is equivalent to 2 times 8, or 2 times 3 plus 5. And they both are equivalent to 16. So like I said, these are called equivalent expressions. You can see that 2 times 3 plus 2 times 5 and 2 times 3 plus 5 are, I'm in the way again, are equivalent expressions. And that's again written here. I have shared these slides with you, so I really encourage you to go back and look at the slides. Right now, I'm just kind of talking you through them, but I encourage you to go through with your notebook and take some notes. Write down those vocabulary words like equivalent expressions and, write down the examples, write down the word term. So go ahead back and just jot down a few notes as you go through the slides on your own. So, did you know that there are several ways to represent multiplication in mathematics? So 5 times 4 can also be written as 5 with a little dot and then 4. This is also 5 times 4, or 5 in parentheses 4. So all three of these, 5 times 4 with a multiplication sign, 5 times 4 using this little dot as a multiplication sign, or 5 being placed right next to the number 4 inside of parentheses, are all representing 5 times 4. There's a really good reason for that. When we get into algebra, we use something called, I know we've talked about this word before, but just as a reminder, we use something called variables. Variables is when you use a variable, you are allowing a letter to take the place of numbers. So X is a letter that we find quite often in algebraic expressions. That is why our fantastic and intelligent mathematicians came up with some other ways to show or to display 5 times 4, or just to display multiplication in general. So it can be a little dot, or it can be these parentheses. So just in case, when you look up here, just in case you weren't sure about that, what this means is 2 times 3, and this means 2 times 5, and this 2 being next to these parentheses means 2 times 8, or 2 times 3 plus 5. So what I'd like you to do right now, why isn't it going to the next? There we go. So what I'd like you to do is to go ahead into your student activity book. We're going to work on problem 4.2, and you are only going to do A, B, and C. So only A, B, and C from problem 4.2. And I have actually given you some space here to type in. But of course, as usual, if you would prefer to do it on paper, could you just take a picture of it and place it on this slide for me so I have it all in one place? That would be great. But you are able to just type right here. So for this one, for C, they're asking you to create a rectangle. You can just go ahead into that insert and go to insert shape and just create a rectangle that way and just label it with the proper numbers. And then they're asking you to write an equivalent expression. Remember, for this, you're just pulling out the 5 and pulling out the 9 so that it will be 6 times 5 plus 9 is equivalent to 6 times 5 plus 6 times 9. And then, of course, you'll just do the opposite on this one. You'll pull out this 4, and then you'll put the 7 and 3 together in those parentheses. You do have some ACE problems to complete. They are going to be problems 7 through 12, found on pages 75 and 76. I've attached onto the Google Classroom a Word document that has all of the questions, number 7 through 12, along with space that you can type in because it is a Word document. So you can just put your answers right there. For those of you who still love the paper and pencil, I'm with you. No worries. Go ahead and just put your answers on lined paper, and that will work as well. If you have any questions, please come see me during office hours, and I hope you have a fantastic weekend. Take care.